Well, we've been now proving angle relationships, and a few moments ago we looked at the angle addition postulate, and now we're going to do a little work with the supplement or complement theorem. And the supplement theorem would state that if two angles are a linear pair, then the sum of their measures is going to equal 180 degrees. And the complement theorem, if the two non-common sides of two adjacent triangles form a right angle, then the sum of their measures is going to be 90 degrees. So supplementary 180, complementary 90. Okay, well, let's get to work here. All right, so we're told here that angle 6 and angle 7 form a linear pair. Now that right there would tell us that those two are equal to, based on the supplement theorem, that the measures of those two angles is going to be 180 degrees. Now further, goes on and says, if the measure of angle 6 equals 3x plus 32, and the measure of angle 7 equals 5x plus 12, find x, find the measure of angle 6, and the measure of angle 7. And then it hits us with this little statement, justify each step. And that's what takes us to a proof. Otherwise, if I didn't have that justify each step, I'd just say that 3x plus 32 plus 5x plus 12 equals 180. Then I'd solve for x, substitute in that value of x into both of those equations, 3x plus 32, that'd give me the measure of angle 6, and 5x plus 12, that'd give me the measure of angle 7. And I wished it was that simple to follow the instructions. Remember, we always have to follow the instructions. That's the number one task. That's the number one. Read the instructions. So let's get about doing it. All right, so we can then say that the measure of angle 6 plus the measure of angle 7 equals 180. That's based upon the congruent supplement theorem. Our reason, our justification is in parentheses. All right. Then we can say that 3x plus 32 plus 5x plus 12 equals 180. That's substitution. That's substituting in what we said both the measure of angle 6 and the measure of angle 7 were as substitution. We're combining like terms, so I got 8x plus 44, in other words, the 3x plus the 5x, and then the 32 plus the 12, that equals 180. That's also substitution. What do you think we're going to subtract next? So we got 8x plus 44 minus 4 equals 180 minus 44. Shazam, that's the subtraction property. And then 8x equals 136. Well, how about that? That's substitution. That's the third time we've used substitution so far. Do you think maybe we're going to divide both sides by 8 next? I think so. 8x over 8 equals 136 over 8. That's the division property. We're just going about solving this. The only difference is we're just popping in what our justifying each step. And let's see, then that's going to leave us with x equals 17, and that was the substitution property. Let's go to the next slide and finish this. We're going to be substituting in x for, substituting 17 for x into both of our equations. And so we start with the measure of angle 6 is equal to 3x plus 32. We've already found x. Now remember, it's 17. Now we're going to find the measure of angle 6 and the measure of angle 7. Let's see. So that means then the measure of angle 6 is equal to 3 times 17, substituting in 17 for x plus 32. And if I combine those like terms, that's going to end up being 83. So the measure of angle 6 is 83 using substitution. Now how about the measure of angle 7? Well, the measure of angle 7 equals 5x plus 12. That's was one of our given statements. And what do you think we're going to do next? We're going to substitute 17 for x. So the measure of angle 7 equals 5 times 17 plus 12, or 97. That's substitution. And I may just want to check myself. Does 83 and 97, not 94, 97 equal 180? Well, 7 and 3 is 10, carry 1. 9 and 9 is 18. Well, Shazam, there we go. Justifying each step. Really not all that different from what we would do anyway. It's just we're having to write down those justifications. Shazam.